Okay, so here we are today at a 200 amp main service panel, electrical. We had just recently installed this one. We're here to add a couple of these arc fault breakers here, and a couple of 15 amp breakers. And I'm going to show you today how to do it. First thing you need to do is open the door. And we enter the panel. Yeah. And here we go. So we got ourselves a run in here already. They just ran this one in a couple days ago, I guess. We'll hook this one in with the 15 amps. And then we need to replace these two down here with them arc faults like I told you. First thing we're going to do is we're going to turn off all the power. And how we're going to do that is we're going to come up here to this 200 amp breaker and we're going to shut it off. Now I think most people think that everything's safe inside this panel, but I'm going to warn you right now that although we're not having any power down here or up here, we're still hot here, here, and here. All four of these are hot, and the only way to make those go off is to remove this meter. Since we're not going to do that, my suggestion is don't touch those four spots or you will regret it. That's my professional advice there. So here, how we're going to change these breakers here. First off, we're just going to remove the wires. Since panels yet to be marked, not too concerned as to where they're coming or going, though we'll leave them in their same bend. That'll keep them kind of good. Yeah. You pop the breaker, simple, simple. Pop them both out like that, and there you have your two breakers are out. We're going to pop out four breakers because we have to put those 15 amps in there. So we're going to pop that one and that one. They're out. That's how easy that is. Putting breakers in, so it's just simple. You take them like this, and you stick them on these bars down here. You have a slot. You want to make sure the slot goes through the bar. Catch it right here in the back. Boom. Boom. Anybody can do that. Alright. Then what we're going to do here is we're going to open up our breakers. Here's our first 15 amp arc fault going in. I like to keep my wires real straight. I don't like those curly Q garbage going on. And we'll go ahead and we'll put him in here. Okay, and then we got one more here. We'll go ahead and get it in right now. Open it up. Unfortunately, it ain't open yet. There it is, and we get the next one. Quite simple. We just untwist the wire, and we're in. Now I am noticing that my neutral wires are way up high. This could cause me some grief. As you can see, they're right here and right here, and we will need the neutral wire to hook up an arc fault breaker. They're required to make it work proper. Got our wires all straight. And we're going to slap the arc fault breaker in just like we did the rest. Now these two wires here will go over here to the neutral bus. This is the neutral bus. It's all these screws along here, and it'll carry both the neutral and the ground wires together. Now in a sub panel, the neutral bus and the ground bus are actually separate. Just a little cautionary habit here. We're going to go ahead and use a needle nose plier to put the wire in, just so I don't get accidentally electrocuted on anything of importance. And here we go. Tighten it up. There's one in. Alright. And here comes the next one. It is sometimes difficult to get the wires in there. Now you see here, and looking at this, that is a very short, stripped out area, and it could end up causing me some grief. So we're going to go ahead and we're just going to lengthen that, and we're going to stick it up in here too without touching those four wires. We're going to get the living crap shocked out of me.
1/2 inch to 3/4 straight.
Yeah, 1/2 inch to 3/4. All right, here we go. In. We got to tighten up the screws. All right there. And right here. This one certainly doesn't want to tighten up. Have it on it right. Ready. Once you get them tight, and they need to be really tight, in the sense that if they're not tight, they'll start arcing. And arcing causes fires. So make sure they're very tight. But, you know, within reason. You don't want to strip out your bolts either. We'll tuck the wire back up in here so that it's kind of out of the way and it looks clean as best we can without getting in this shocked. Okay, those two are in. We'll now retrieve our two ground wires that were hooked into the normal circuit. These are neutral wires, I'm sorry. And we'll move them down. Okay, so we're back here doing this. We had to move our two arc fault breakers up top because our neutral wires are too short. So going back into why these neutral wires are important here is that in order to properly arc fault the breaker, your neutral wire has to be on the same circuit as your hot wire. So these two are together. They're on the same wire, on the same circuit, and these two are a different circuit. So then the arc fault goes down here. We'll tuck these wires in nice and pretty, yanking these out. Tucking these in nice and pretty without getting electrocuted again. And you can see some nice big sparks from time to time working on these panels. It isn't pleasant, I'll tell you that much. So we stick our arc fault, goes down there, our neutral. We'll back out our screw here and make sure that we got our neutral in. Sometimes they like to close the screws up on us. So as we put the neutral in the neutrals bus. Alright. Looks like it's getting tight. Alright, so then what we do is we pull the wire to make sure that it is tight, and it is tight. Then we'll stick on our other neutral since we know it's this one here, and we'll set it in there and we'll put it on the breaker above it. Alright. Here's the screw up because it looks like the screw is tight. And then we're in. And then we'll try and tighten it down again. And we pull on it again to make sure that it is tight. And it is tight. And there are our neutrals. They're in and ready to go. Now we'll put our hot wires in. Now each hot wire has to go to the same breaker that its accompanying neutral went to. You cannot separate, cross, or otherwise do it. And also with an arc fault breaker, one of the most important things is that your neutral has to be dedicated. It cannot be helping operate other circuits, which is a common thing we like to do on using like a 12-3 or 14-3 wire. Look at that arc fault breaker. It's got screws in there sideways or something. What the hell? There it is. So there he goes. Tighten it up. And there we are. Give them bird's eye too so you can see the whole thing. Alright. And that one's in. So we'll put in our next wire and our last wire for this part of the task. And that is this wire right here. And we're going to go ahead and put it in the breaker above. It'll be the right breaker accompanying the ground wire, the neutral wire. Sorry. And we'll go ahead and we'll toss it right up in there. There we are. I work a lot of hot panels, so I don't like sticking my hands in them, even when they're off. Because, well, yeah, we're just biting the heck out of you. And I'm working really close to these stupid hot rings. Alright. So we'll pull this wire too. It's tight. This one's tight. Those are ready to turn on. But before we do that, we're going to replace these two 20 amps that we took out earlier because we need the spaces filled. Because we're going to have a holiday. And then we take on this wire. This here is a 14-3 wire. It'll need to be stripped. Unfortunately, its neutral is not shared because it is an existing circuit, meaning that it's coming from a junction box somewhere. And since it does not have a dedicated neutral we cannot actually give it an arc fault breaker. So what we can do though is we can, of course, heat it up with the standard breakers. And what you want to do about stripping wire, and you can give them a better bird's eye view, but what you want to do about stripping wire is not cut the wire underneath the sheath. The dings will allow an area for you to be electrocuted. All right, and here we come. So we come in here, we take this, get the paper off, get the hair out of it. Most importantly, get the paper off. This paper is being nice and stubborn. Alright, and we got to wrap with the hair. And basically, we got to do, that goes a lot of the hair. What we got to do here is cut the wire off deep in the back. Now, the most dangerous wire that we're working with here, oddly enough, happens to be the ground wire, this bare wire. And the reason that one is so dangerous right now is because if so much touches any one of these things here, and I'm touching this ground wire, I'll be electrocuted, guaranteed. So we're going to try and just install it without touching that darn thing. It's kind of nerve-wracking. I'm not horribly stoked on this particular step, especially when I'm within inches of those main lugs. We pull the ground wire in just beautifully, and we roll back up this way. So we can get a nice loop in there. I don't like making my wires too tight because then if you have to do any work in the panel, things have to move, you're stuck with short wires. And that's just lovely when you do with short wires. Splices are unwelcome. We'll cut the slack off, get rid of it.
What's up?
Okay. Okay, so here we go. We're putting the neutral wire in, the ground wire in, and it's in. Second wire, all the rest of the wires are less dangerous because they will not conduct when they touch the main lugs. So you gotta stay away from the main lugs with any of these ground wires. Just push them back. All right. Now we come on in here with the final wire, and it's our neutral wire. And once again, it's long. We like to loop it in because we don't like tight wires. Gives us the ability to make changes. So we'll come back up here without touching anything. Pull our loops, nice little loop down there. We'll go ahead and cut and strip. So cut, strip, pretty simple. All right, there it is. Let me take this here. Put it into that lug there, and we just tighten down the screw. That is our neutral inner ground on our 14-3 circuit. Basically, what we'll do here, wonderful. We'll do here is we'll make sure these are tight. They all look really tight. And then we'll use these here, and smush it to the back a little, keep those wires out of my way. Okay. Now these two wires here are each an individual hot circuit, all by themselves. We'll run them down here. Once again, these ones will not conduct if they cross the hot lugs. Shoot, I'm within like centimeters. And there we are. All right. We'll bring these back up, we'll bend them in, we're about finished. That's how fast this should go. It's really not that hard, but it is quite dangerous, I guess. You make a mistake, could be your last. All right, we'll go ahead and strip them down. There we go. And there we go. And we'll take this, choose a breaker. Since these are not arc fault, you can, the neutral doesn't matter. And we'll have to mark the breakers since it's an existing circuit and we figure out exactly what it does. We just know that it's 15 amp and there's 2 of them. Alright, that one's nice and tight. There we are, looks good. It's a little bit busy in here, but not even nearly as busy as you can get. Kind of straighten it out, make the wire look a little bit decent. We don't want it looking ugly. Stick it in here. Alright, stick it in here. Alright, and there you got it. Now we're going to do one more thing. What about it? They're good? Something wrong? That's good. They're tight. They're tight. Yeah, they're tight. We're good. Okay. Moving on. What am I doing? Oh yes, the last part here is this. So because we've moved our 2 arc fault breakers up to the top, instead of down here at the bottom where they were, we'll have to take the door and make it a little wider. It's pretty simple. That's the close that. We're able to put the door back in. Everybody fits beautifully. Right. Go ahead and put our bottom screw in because you don't want to. Oh, we like perfection. Come on. We'll turn on our 200 amp main again. Boom. Everybody should be darn hot. 2 15s, 20, 20. And they're on. Now, you know what, guys? Sorry about this, everybody, but there is a slight redo here in the fact that I do want to do one last thing. Oops. Sorry, my perfection requires me to try and make sure that our loads are good. Arc faults usually don't have to worry about because if they're not, they're going to kick. So you can see my tester here. We're looking for 120 plus volts or 118. That is amazing. Oh, that's sorry. Huh? Wrong lug. 123. That's a little high, but it works. 123 again. We're good. We're going down here to these 15 amps. We're testing off, by the way, just so you know, we're testing off. 1 off the neutral. That's requirement. And 1 off the hot. All right, off the screw and the breaker. Stick it on the breaker and you'll see it. 122, 123. There we are again. And 122, 123. So here you've learned how to test your breakers. You've learned how to remove and install breakers, and you learned how to do an arc fault breaker. Some people actually pay for that. Anyway, remember to subscribe to my site and click on you like the video. Otherwise, well, we won't be able to tell you too much more about electricity. Have a good one.
That wasn't paused.
Bye. So here's the sub panel right here. We just got done working on the main a second ago. And the biggest difference between a sub panel and a main panel, well, besides the fact that PG&E doesn't get them here directly, is that if you look right here, you got this big metal bar here. That's called the neutral bus. In a main panel, the neutral bus and the ground bus are the same. But in a sub panel, you end up with another bus right up here that has to be installed after purchase, and that is your ground bus. And the important thing that we do here is we keep our loops long. A lot of electricians like to go in straight, really tight wires, and although that's great for the finished product for the moment, when changes and retrofits have to occur, it's nice to have some length, especially during panel replacements and other things that we end up having to do. Anyway, this is the sub panel, very similar. And if you look in this way, this right here is what's called a water bond, and it's your water heater closet. It's a gas hot water heater. You can see the gas pipe here. Actually, I'm sorry, this is the drain. The gas pipe's down there. See it down there, and you can see behind it we have this wire. And basically what a gas bond is just a ground clamp down there onto the gas pipe, and it comes up across here, and you get a clamp here on your hot water pipe. See the clamp up there, hot or cold, it doesn't matter, because you're going to have one over here on the other pipe, which is one of the other. And actually your cold water, because there's your handle. So there you go, and that's how you do a what's called the your gas bond. That's what's called your gas bond. So There's a gas bond right there. Every house is required to have one. If you don't, better call your electrician or do it